Okay, so in the previous video, I said in this video I would look at solutions to differential equations, but that's wrong. I want to look at solutions to non-algebraic equations. So when I say algebraic equations, basically I mean polynomials. I think you can see how you would extend the example up here to higher degree polynomials. But let's look at like solving sine of x is equal to 0. We know sine of x is equal to 0 when x is equal to 0 and 2 pi. So let's look at stuff like that. So let's first, let's say our function is going to be sine of x. So f is equal to sine of x. And I'm just going to run this just to make sure I haven't done anything wrong. Whoops, and I have. That was on purpose. Not really. So sp.sine is what you need to know to tell Sympy that you want, or to tell Python that you wanted to use the sine function in Sympy. Okay, so there we go. And now I'm going to say my equation is going to be equal to f, and I want it to be equal to 0. So in other words, like I said in the previous video, what this is saying within Python, within Sympy, or however you want to look at it, it's saying there is an equation. The left-hand side of the equation is sine x. The right-hand side of the equation is 0. And now we're going to solve it. So we're going to put equation. We want to solve this for x. We're going to call this the solution. And I'm going to print the solution. And when I print it, I think it will say 0 and pi. Yes, so it gives the solutions 0 and pi. If you want to use the actual symbols, you can do pprint. I think that's pretty print. Sometimes pretty print looks awful. Sometimes pretty print looks a little bit better. Sorry, it's sp.pprint. And you get something that looks a little bit better than just pi. Anyways, I'm probably going to stick with print most of the time. Okay, so let's look at another example. Let's say we want to do an exponential function. So let's say we have x is equal to sp.exp. I think that's the right name. Looks like it. And let's say we want to do something a little interesting here. So we know e to the power of x is never equal to 0. Let's see what happens when we set it equal to 0. Whoops. And then, okay, so what this is saying, again, this line says, EQ is going to be the equation e to the power of x is equal to 0. This says this sp.solve is going to solve the equation, and we're going to store it in the variable called sol for a solution, and then we're going to print that. And when we run it, we get nothing because there is no solution. On the other hand, there is a solution to e to the power of x is equal to 1. That's what this equation here says. We're changing the right-hand side to 1. There is a solution to that equation, e to the power of x is equal to 1. Maybe you should think about it before I run the code. Pause it for a second. Okay, hopefully you paused it and thought about it, and when we run the code, we get 0 because e to the power of 0 is equal to 1. Okay, so this is using Sympy to solve different non-algebraic equations like sine and e to the power of x. You can look at the Sympy documentation. I also posted the link in this module to my differential equations notes, where I also talk extensively about Sympy and solving equations. You can look at the different functions that Sympy has that you can use it to solve equations. I'm going to look at some more equations in the next video, and in the video after that, I'm going to look at basics of solving differential equations using Sympy, or maybe I should say doing calculus stuff for a couple of videos. But that's it for this video.